All right, students, welcome to the third and last part of the video for looking at some applications of derivatives. We focused a lot on physics, velocity, acceleration, position functions. Now we're going to just do a little bit of economics. And first of all, to begin with, we have rates of change, of course, in economics with interest rates and so forth. So in economics, the word marginal refers to a rate of change, which is going to be represented by the derivative. So we're going to look at some functions. We have a total cost function, which gives the total cost of producing whatever items, X items that you're producing. And the marginal cost is the derivative. I have a total revenue function, the revenue brought in by a business. The marginal revenue is how that revenue is changing as you produce a different number of items, and that's represented by R prime. Total profit is just the revenue minus the cost. So if a business is going to calculate its profit, they have to look at the difference between all the revenue they're generating by selling something and subtracting off the cost that it takes to run the business. And the marginal profit would just be the derivative then. Okay, so to begin with, let me go down here and talk a little bit about what the cost function means. So the total cost function, C of X, represents a sum total, and the key word is all items of X. All right, so C of 20 is not the cost of the 20th item, it's the cost of the first 20 items. So it is a grand total. All right. The total cost of producing the next item, so X plus 1 would just be the next item, is C of X plus 1, and then the total cost of just X items, of course, is C of X. Now, the exact cost of whatever item, what you do is you take the sum total of all minus 1 less. So in other words, this is something that's probably worth writing down. Say that you have C of 10, you want to find the exact, let me write this like this. It's a little bit better to write it like this. Okay, so let's say that we want to find the exact cost of the 10th item only. Okay, well, the way this would work out is you would take the cost of all 10, so that would be all of your first 10 items, and then you would subtract off the grand total of the first 9 items. And then the difference should be the exact cost of that specific 10th item. Okay, does that make sense? Okay, all right. So remember, a total cost function can be used to find the exact cost of a specific item. Okay, so to go down here at the bottom, this says a company manufactures automatic transmissions for a car. The total weekly cost in dollars of producing X transmissions is given by this function. And this is a total cost function. So in other words, if you did C of 5, that would be the cost of the first 5 transmissions, just as an example. Okay, so first thing we're going to do is find the marginal cost function. Well, the marginal cost function is just the rate of change of this total cost function, so we do the derivative. So the derivative of 50,000 that's a constant, so that's 0. The derivative of the linear term, 600x, is 600. And then the power rule, we would just write down the constant 0.75. The derivative of x squared is 2x the first. Now, you don't have to write this step. You can do this all in your head. So we get 600 minus 1.5 times x. So that would be your marginal cost function like that, which is found just by taking the derivative. Okay? Okay, now what we're going to do is find the marginal cost at a production level of 200 transmissions per week. So that just means we're going to take the marginal cost function that we found by doing the derivative, and we're going to evaluate that at x equals 200. So we just do 600 minus 1.5 times 200, and then that will give a rate of change when the production level is 200 transmissions per week. Okay, so I can do this on the calculator. and get what that marginal cost is. So the derivative is 600 minus 1.5 and then times the 200 transmissions. And this could be positive or negative because it's a derivative. It can be increasing or decreasing. So this is $300. Okay, so that's the marginal cost. That's the rate of change at the production level of 200 transmissions per week. Okay, so we're going to interpret what these things mean then. So in part C, it says interpret what we mean by the marginal cost of 200 transmissions per week. So what it means is this. At a production level, and you want to write this down specifically like this, at a production level of 200 transmissions per week, that's important that you're stating that. Then what's happening, remember this is a slope. Okay, so a slope is a rise over a run. So what this really is this is a change in cost. Okay, that's a cost. That's a change in total cost. And then that would be the change in number of transmissions. Okay, so there's several ways you could say this. One thing you could say is at a production level of 200 transmissions per week, you could say the cost, and I would say is increasing. That's because it's positive. So the cost at this point in time is increasing at a rate of $300 per transmission. Okay, so a lot of times what we do is we use this to represent the approximate cost of the next item. So another way to say this is this approximates the cost of the 201st transmission. And that's what we're going to learn. That's what a marginal cost basically does. That approximates that. So what we're going to do is do the exact cost of the 201st transmission. So in order to find the exact cost of the 201st, we have to do this. We have to find the grand total cost of all 201. So that's all 201 transmissions, the first 201, and then subtract off the grand total of all of the first 200. Okay? So what we have to do is we have to go not to our marginal, but we want to go to our basic cost function, which I have highlighted up here in yellow. Okay, so we're going to plug into this. So it's going to go like this. We just do 50,000 plus 600 times 201, and then minus 0.75 times 201 to the second power. So that right there gives you the cost. That basically is the cost of the first 201 transmissions. Now we're going to subtract off the cost of 200, so it's the same thing except we're evaluating at 200. So it's 50,000 plus 600 times 200 this time, minus, and that was a 7.5, wasn't it? So I didn't quite catch that. There we go. Let me get that correct. I'm glad I saw that. So 0.75x to the second. And here this would be 0.75 times 200 to the second power like that. Okay, and again, what this does is that gives the cost of the first 200. So the difference between those should give the exact cost of the 201st transmission. Okay, so we'll just do this on the calculator, and I'll go ahead and just do each of these things one at a time. So the first one we have 50,000 plus 600, 600 times 201, and then minus 0.75 times 201 to the second power, and that will give the cost of the first 201 transmissions. That's a lot of money. That's a lot of transmissions. So that's going to be $140,299.25. Okay, now we're going to do the cost of the first 200. So we do essentially the same thing except evaluate at 200. So plus 600 times 200 this time, and then minus 0.75 times 200 to the second. This will be a little less, so that will give $140,000 then. Okay, so if we subtract those two, we're going to get $299.25 then. Okay, so let's kind of go through what I just did here, and this is what I'm trying to show you. When we did the marginal cost of 200, what I said is you can interpret this as being approximately the cost of the 201st transmission. Now it's not exact, but it's approximate. So this thing is a good estimate for the cost of the next item, like that. So those things will be off a little bit, and then we'll talk geometrically in a few minutes why that is. Okay, so just to show you kind of what I did and summarize what I did, this was a cost function. The marginal cost function is simply the derivative. We evaluated that derivative at 200 and got $300. That means that when you are producing 200 transmissions per week, then the change in the cost of the transmission is $300. So you can use the marginal to approximate the exact cost of the next transmission. So if we did the marginal of 200, that approximates this. All right, and this is worth writing down on here. So when we did the derivative of 200, that is approximately the exact cost of the next item. Okay, that's what you want to get down, is that right there. That's an approximation. Okay, so I'm going to let you pause the video and go ahead and try this. Just kind of run through a similar idea and see if you're on top of what I just showed you. Okay, so let's go ahead and take a look and let's see how you fared here. Okay, so this is your total cost function for X electric guitars. Marginal cost is just the derivative. You can do that in your head. That's 100 minus 0.5x. The marginal cost at 50 guitars per week just means evaluate that. So it's 100 minus 0.5 times 50, so that's $75. In interpreting this, there's two ways that you want to think of this. At a production level of 50 guitars per week, the cost is increasing at $75 per guitar. You can think of that as $75 is the approximate cost of making the next guitar. That's the idea. And then when you do the exact cost of the 51st guitar, you do C of 51 minus C of 50. And if you do the arithmetic correctly, you would have got $74.75. And what you want to notice is those things are pretty close to each other. So this is a good approximation of this. Okay, that's the idea. Okay, so let's move to the next page. And we're going to kind of go over the why that's a good approximation. So I'm going to go over this graph a little bit and kind of take you through the analysis of this. So first of all, this is kind of what we just looked at, is this marginal is an approximation of the exact cost of the next item. Okay, so I'm going to show you kind of how this goes in here, and you got to think through this just a little bit. So first of all, first thing is C of X that's the graph in blue. So that is the cost function. So what we're interested in is this. Let's just say, for instance, that this is like the last example. Let's say that was the 50th guitar. Then the total cost would be whatever that Y value is. And that would be the total cost of all 50 on that. Okay, this would be the next item. X plus 1, let's just say that is the 51st then. Okay. Remember, we said the exact cost of the 51st should be close to the same as the marginal of the 50th. So what I'm trying to show you is just specifically like the problem we just did. What that is that marginal, that is the slope of a tangent line. All right, so that's the slope of a tangent line, and that approximates the exact cost of the next item. So I'm just using this as an example to kind of help you see why these things are fairly close. So that would be, again, the exact cost of the 51st guitar, like we did in the last example. So anyway, this is kind of how this goes. This would be the slope of the tangent line. So the slope of this tangent line would be the marginal. Okay, and let's say if that was 50, then the slope of that tangent line would be the slope of the tangent line, the 50th. Well, a slope is a rise over a run. So here's the rise right here. That's your rise right there. And here is your run right here. Okay, well, that run is 1. So the run is equal to 1. So what that would mean is this piece right here would be what that marginal is. So the marginal would actually be that part right there in blue. It's rise over run, so it's this over 1, therefore it's that amount right there. So that right there is the value of the marginal. Okay, so this thing right here that would be C prime of 50. That's what that is. Okay, now what is the exact cost? Well, the exact cost is this item. Okay, that would be C of 51. So if you followed that over, C of 51 would be that Y value. C of 50 would be this Y value. So this little piece right here, that would end up being the exact cost. Okay, so what you kind of have here is that part there, that's the exact cost. And then the marginal is the part in blue. And then this little piece right here, that would be the error. So that distance from there to there would kind of be the error in our approximation. So think about that a little bit. That's how that diagram shows visually what we just got through doing. Okay, so that's the main formula we're going to work with. Okay, so let's go down. We're going to go to one more page. This is the formula I just developed for you. And so let's go to the next problem, then we'll kind of wrap this up then. Okay, so this says the total cost in dollars of producing X food processors is given by that total cost function. We're going to go ahead and find the exact cost of producing the 21st food processor. So, well, like we learned when we're doing the exact cost of the 21st, what do? We do the total of all 21 minus the total of the first 20. Okay, so we're going to plug in and evaluate that then like this. Now this time I'm going to let's do this graphically. It's kind of good to do some of these things graphically. So in the calculator, just do this with me. Go ahead and put your cost function in, which is 2,000 plus 50x. This is a quadratic function, so it'll be a parabola open upside down, and then plus 0.5 x to the second. Okay? Now, for a viewing window, now we're kind of interested at the 21st. Let's go, I'm just going to play with this a little bit and say X is 0 food processors. The max, let's go up to 50 food processors and maybe scale by 10. Okay, for Y, Y is money, that's the cost, so the lowest cost would be 0. I would go to my table of values to get a sense of how these costs are. So the costs look like they're increasing, at least for a while. That's up in the 2000s. So why don't we go up to about maybe 5,000, and we can adjust if we need to. So I kind of look at that table to get a sense of how to set this up. Okay, I'm going to graph it real quick. Let's take this out maybe a little further. Let's take this out maybe to 100. And let's take this to 4,000. Okay, I don't think I need to go up that high. So let's try that. And that's kind of how I do a window. I just sort of adjust to get a sense after I look at the table of values. Okay, so here's the graph. Oh, what did I do? I must have totally put the wrong window in. Oh, I didn't go up high enough. Okay, So if something doesn't come out on your calculator, you pretty well know something's going wrong there. So I'll slide this over here. And then what we're going to do is a couple of simple things on here. So that should have been 4,000. Well, we're going to just trace out at this. So you can trace on this. So we're just going to trace at 21. And see, that will give this y value. So that's given as this number. Okay, so let's just write that down as $2,829.50. So that's the cost of the first 21 items. Now let's trace at 20. Okay, that'll have a little bit lower y value, so that is $2,800 then. Okay, now we can look at the difference between those two then. So that looks like that would be, what is that, $29.50. So that's how much it would cost to make that 21st food processor like that then. Okay, so we're going to use the marginal cost to approximate this cost. And it goes like this. Remember, what we just did is we just did the exact cost of the 21st item. So we do the marginal of 20. Remember, the marginal of 20 approximates the cost of making the next item. So what we have to do is two things. We have to do C prime of x. So we do that derivative, which is just 50 minus 0.5 times 2x. Or, again, just do that in your head. That's 50 minus x is what that is. So then we're going to do C prime of 20, the marginal cost of 20 items. So that would be 50 minus 20, so that would be $30. Okay, so what I'm showing you on this then, see the answer to these two problems should be pretty close, is this approximates this. So what I just showed you on this is it kind of goes like this. C prime of 20, which was $30, approximates the exact cost of the next item, which was $29.50. So that's how that works out. Okay? And doing this graphing on your graphing calculator kind of speed up your arithmetic because you can just trace out those two values like that then. Okay, so to wrap this up, let's go ahead and I'm going to have you do this, try this problem down at the bottom. It's pretty similar. Do a graph on this too and see if you can get this one put together okay. Pause the video, come back and check, and then I'll wrap us up. Okay, so let's go ahead and see how we did here. Okay, you can look over my answers and see if they match yours. Okay, I think I got everything right here. So the exact cost of the 25th would be C of 25 minus C of 24. And again, I graphed that on my calculator. I just did the graph and I traced out C of 25 and got this. Traced out C of 24, got that. So the difference between those two is $140.20. So that is the exact cost, according to this cost function, of that bicycle. Okay, the 25th bicycle. Now the marginal cost, you should have done the derivative. Your derivative of this function is 150 minus 0.4x, evaluated at 24. Now don't get that backwards. Remember, the marginal of 24 gives the exact of the next, or it approximates it. So you had to evaluate this at 24. So notice that this thing was pretty close to that. Okay, that's a good, only off by 20 cents. That's an approximation. Okay, so that'll wrap that up on the economics. That's all we're going to do on that section. Good luck on working with your physics and a little bit of economics. This will give you a beginning introduction to some basic applications of differentiation. Good luck.